Hey everyone, in this section we are going to learn some of the miscellaneous topics which are part of statistics but are majorly used in machine learning. So in that journey we are going to learn about the resampling techniques in this video. So as we proceed, we'll look into the various methodologies that we have under this resampling. First of all, let's understand what exactly is this resampling. Now, resampling method is actually a tool which is consisting in repeatedly drawing samples from a data set and calculating the statistics and the metrics on each of those samples. Now, we actually do this to obtain further information about something, and in machine learning setting, this is something is now I repeat, now in machine learning setting, this something is the performance of the model. Now the question is why we have to use this. So every time whenever we draw a sample from a population and calculate a statistic, the estimated parameter can be far or it can be as close to the real population value. And this can be due to the random chance. So therefore, we don't have any information about the confidence of our conclusion and our prediction will be dubious. So just think about it. Whenever you have been given with the population of the data, let's say you've got million records. Now you have decided that you're going to do the analysis on 1000 rows. Now when you choose that 1000 rows, how can you validate whether this 1000 rows is going to represent the population itself? That's correct, guys. That's correct. That's where the resampling comes into picture. Now, whenever we are performing the model selection, some of the commonly used resampling techniques are cross-validation and bootstrapping. Now, under this cross-validation, we've got k-fold cross-validation technique and another method of cross-validation which is called as leave one out cross-validation technique. So let's understand what exactly is this cross-validation. When I say cross-validation, it's a resampling procedure to evaluate the machine learning models by splitting the given data into train set and the test set. Now, under this cross-validation, we've got k-fold cross-validation technique. Now, this k-fold cross-validation technique is a technique which overcomes the issue of high bias due to the splitting of training data, and therefore by generating k-folds and performing the refitting over k iterations. So the steps that we follow in this k-fold cross-validation are: first, we are going to create k-fold. That means we are going to randomly shuffle the data into k-folds, and for each fold we are going to consider it as a test data and remaining k-1 fold as a training data. And then we are going to perform the fit with k models. So which means that if I have k models with me, then on each model, whenever I'm trying out, I'll have one part of data as my test data and remaining k-1 part of my data will be my training data. And we will be evaluating for each k models on the each test part. And finally, we are going to summarize the evaluation using the metric that is mean. So this is the overall concept behind this k-fold cross-validation. Now, apart from this method, we also have LOOCV method, that is leave one out cross-validation technique. Now here, this is actually a specific type of k-fold cross-validation technique, but in this scenario, we'll only have one observation, that is one row will be my test data, that is my validation data, and remaining data will be my given data set. Now in this LOOCV, the number of folds, that is k, equal to the number of samples that we have got in this data set. Now in this scenario, we are going to use all the training data and we will use one data as a test data or a validation data. So as a result of this would end up in creating the model which will have low bias, but since we have to repeat it for n number of samples, then in that scenario, I would say that this is actually a computation heavy. And the another technique that we have got is called as bootstrapping. Now in this bootstrapping, the number of bootstrap sample is actually decided. And based on the decision, we are going to decide, and randomly select the data with repetition. So the steps that we follow is, first we'll decide the number of bootstrap samples, and then we will also decide on the size of each sample. Then we are going to extract the samples of desired size, and for each sample we are going to select the samples with replacement. And this is a common technique whenever we are working with the models such as the random forest models. Alright, so as part of your learning journey in this video, you have learned about the what exactly is this resampling method and the various resampling techniques that we have got for model selection. In the upcoming video journey, we are going to perform the cross-validation in a hands-on manner. So I'll see you in the next video. In this video, let's look into the solution for this project number 23, that is flight price prediction. So let's get started and let's see how we can implement a solution for this problem statement of flight price prediction. I'll come back to my Google Colab. Alright team, now let's see and let's understand how this notebook has been implemented. So the first thing over here is I'm going to download the data set. So this will download the data set. Now once the data set has been downloaded, we'll import the necessary libraries, NumPy library, Pandas library, as well as Matplotlib library. Okay, so the file has been loaded as well as the libraries has been loaded for us. Now once the library has been loaded, we'll import the necessary data set. I'm going to say dftrain is equal to pd.read_excel because the training data is in Excel sheet format. So we'll read this Excel file, and I'm setting some options over here for my data frame so that we can view the complete columns that we have got when we see the df.head. Okay, else what happens is we will be restricted with the number of columns that gets displayed when we call data frame.head. So these are the list of columns that we have got on this data set. Okay, now let's try to understand the overall information about this data frame. So in this data frame, that is in this training data, we've got 10,683 rows, and in total we have got 11 columns in this data set, and we have each column and its respective data type. The airline refers to the airline company. It is in string format. Date of journey, which should be actually date, but it is read as a string format, which means we have to do some type of pre-processing over here. We've got the source. Source refers to the place. Okay, so here for the source it is mentioned as string. For destination, so destination here it is mentioned as string as well. Okay, that is great. And route, obviously it will be string. Departure time is also string. So we can see that wherever it is dates and time, it has been detected as a string data type itself. The final column price, that has been detected as a floating point number. So this is what we can observe from this given data set. Now let's look into the various frequencies of the columns that we have got for duration. So if I say df train and select the column of duration. So duration is the column which describes the duration of the flight, that is the total duration of the flight. So if I display the value counts for this df train, so this is going to tell us how many number of unique entries that we have got and its respective frequency. Okay, here it says that for the flight which is having the journey time of 2 hours 50 minutes is having a frequency of 550. That means out of this 10,000 plus records, I've got 550 rows which has got this value of this duration. That is what we observe on this given data set. And even one key thing that we can observe over here is, so for the column of total stops, I can see a value missing. For the route, there is a value missing. So we can see that these two columns have the missing values. So what I'm going to do is I'm going to drop the missing values from this data frame. So df train drop NA, and this is going to drop the missing values in this data set. Now once I drop the missing values, if I say df train is none, so this is going to confirm us that there are no missing values on this data set. Okay, so this is what we can observe from this given data. Next, here we'll start with EDA. EDA is nothing but the exploratory data analysis. So one thing that we have understood, especially when we were displaying the information about this data frame, is the columns like date of journey, duration. So all these columns is actually in the format of object, that is the string format. But we have to format it in the right way so that we can effectively perform the analysis on the data set. So to begin with, we are going to consider the column of date of journey. So this date of journey column is in string format, and we are going to convert it into the date time format, that is the timestamp format. So for that, I have made use of pandas dot to underscore datetime function, which will help me to convert the object data type into the datetime data type. So here df train journey day, that's the new column that I'm going to create, and I'm saying that pd.to datetime, I'm selecting the column, I'm specifying the format, and then I'm selecting the day. Okay, this is going to extract the day only, which is the day of the date. In the same way, when I say dt.month, this will extract only the month of that date. So I'll just execute this, and I'll execute this cell as well. And now if I display first few entries of this data frame, so this is how the first few entries of this data frame would look like. We've got airline, date of journey, source, destination, and so on. And at the end, we have added two new columns, journey day and journey month. So journey day has got 24, like it has extracted only the dates, and journey month has the month information. Okay, we have extracted date and month from this date. Then once that is done, obviously we don't require that column anymore. Hence I'm dropping that column which says as date of journey. So I'll just drop that column right here. Next, in the same way, I'm going to extract the information here. I'm converting the departure time into the date time format. From there, I'm extracting the hour, and I'm also extracting the departure minute. Okay. So once that is done, I'm going to drop the column of departure time. So once this pre-processing is complete, if we now try to get a quick view of this data set, so we have added two new columns, departure hour and departure minute. Okay, next here, going further, now we are extracting the arrival time, and once we have extracted this arrival time, we are extracting the hour and the minute from this data frame. So data frame arrival time and data frame, like from the arrival time, we are extracting the hour and minute. So once this is done, so we are going to drop the same and we'll display the first few entries of this data frame. So we can observe that this is how the pre-processing would look like. So we have just extracted the hour and minute for the arrival. So you can clearly observe we are taking a step-by-step approach in analyzing this data. And then I'm creating a new variable called duration, which will extract the values from this duration. Then I'm going through each and every duration and I'm adding this information. I'm saying that if hour is present in duration, I'm just adding it like this, 0 minute and so on. Else I'm adding it as 0 hours and so on. I'm just going to do the pre-processing, and once that is done, okay, once that is done, if I go ahead and perform the pre-processing and display the final data frame, that is the df.head. So at the end, we have actually extracted the hours and minutes, the total journey hours and minutes, that is the total journey duration. That is what we have extracted from this given data. Next thing is, obviously, if we are into applying the machine learning model, we have to find an effective way to convert the categorical data into a numerical format. So in our scenario, so just to help you bring back the memory, so whenever we are dealing with the nominal data, in that time, we have to make use of one hot encoder. And when we are working with an ordinal data, at that time, we have to make use of label encoder. So that is one key thing that you have to remember. Now, when I talk about the column of airline, so airline column is a nominal data. So since it's a nominal data, obviously the preferred method will be the one-hot encoding. Now, before that, so here I'm creating a plot right now. So I'm writing it as sns.catplot. I'm specifying the column Y as price and X as airline, and I'm considering my data frame. In this data frame, I'm sorting it on the basis of price. Okay, now once I execute this, this is going to help me to create a box plot. See, this has created a box plot, and here from this I can say that the Jet Airways business is the one which is a costlier one, and the lowest one I would observe over here is TrueJet. Okay, that is what we observe. And SpiceJet and Indigo are among the economy based carriers, and that is what we observe in this given data. So this has helped me to understand how does the various airlines stand in terms of their prices. Now, since it's a nominal data, as I mentioned, we are going to perform the one-hot encoding. So I'll perform this one-hot encoding and I'm storing it inside a variable that's called as flight. So this has converted the data into a one-hot representation. Now, once that is done, we are going to display first few entries of this data frame. And then here, I'm saying that DF train source, and going further, we're also going to perform the analysis on the source as well. So from the source, we don't see much of a variation over here. So from the Bangalore is the one, I would say it's the lowest median price I would observe, but it's not much differentiable. So that is what we observe from this given data. Now, since this source contains the source, which is a string column, so string values, so we'll also perform the one-hot encoding. So this will take care of one-hot encoding on the categorical values of the source. In the same way, we will perform the one-hot encoding on the destination column as well. So these are the destination, and we'll apply the getDummies, pd.getDummies, and then once we apply the one-hot encoding, so this is how it would look like. Then we'll extract the route. So these are the routes information that we have got. Since these are not adding much information for us, so I'm just going to drop this column route and additional information from this data frame. And here we have got something called as total stops. Total stops describes how many number of stops have actually occurred between source and the destination. Since these are also represented in a string format, so we will convert it into a numerical format. For that, we are applying the replace method and replacing the values as per our expectation. If required, we can also make use of map function as well. So you can use any of the method in order to do this encoding of the string values into a numerical value. Now, once that is done, so we will display first few entries of this data frame, and this is how the first few entries of this data frame would look like. Next, I am performing the concatenation. So this will perform the concatenation of all the data that we have done and extracted: airline, source, destination, total stops. So along with that, we also have the one-hot encoded columns as well, which we have created individually. Since we now have the one-hot representation of this data, we can go ahead and remove these columns. So we can just go ahead and remove these columns over here. So I'll just remove the columns, that is airline, source, destination, since we have already taken care of it. Now once that is done, so this is how the data frame would look like. Okay, this is how our data frame would look like. Now in our entire data frame, we have the numerical values. So we now have the numerical values in this data frame. Now once that is done, we'll display the shape of our data frame. So this is the shape of our data frame, and post that we will read the test data, that is test.xlsx, and then we are going to perform the similar kind of pre-processing on the test data as well, which we have done on the training data. So this cell has the same code which we have written earlier in multiple cells for the training data. This will ensure that we are applying the same kind of pre-processing on the test data as well. Now, once that is done, we are going to separate the X and Y. Okay. Once we separate the X and Y, so we can then go ahead and plot the correlation to see if we have any correlation between the features. So you can go ahead and perform this correlation analysis. So for now, we'll just proceed and I'll show you the important things. So in this scenario, I'm applying the extra-trace regressor. So extra-trace regressor is a machine learning model which comes under ensemble learning technique. We are using this extra-trace regressor, and this regressor will be using it to extract the important features. So in order to extract the important features, we are going to use this extra-trace regressor, and here I'm going to extract the feature importances. Okay, next, once I have extracted the feature importances, I'm going to display top 15 important features from this given data. So these are the top 15 important features from this given data. So we can say that total stops plays a major role over here, and journey day is an important, Jet Airways is important. So these are the features which are very important for us in order to establish a relationship between features and the target. So now this time I'll be using the random forest algorithm. Alternatively, you can also make use of linear regression as well. Now in this example, I'm just showing you as how we can apply a machine learning model of random forest. Since it's a regression task, so we'll be using the random forest regressor. I've split the data into two parts: initialize the model, perform the fit on the data set, generate the prediction, get the score. So this will help me to display the score, and then once that is done, we are going to find the score on the test data. On the test data, the score is closer to 80%. And now if I create a displot with y hat minus y test, that is the difference between the predicted values and the label values. So this is how the overall distribution would look like. Okay, so this is the overall distribution of the data, and we can also try creating a scatter plot as well to see how does the plot would look like. And you can go ahead and check out the various metrics as well. So mean absolute error, mean squared error, and root mean squared error. Okay, and finally you can also calculate the R2 score, so which will help us to describe what amount of variance can be explained by my features about my target data. So here, what we have done in this overall implementation is I gave you a quick walkthrough as how does the flight price prediction task would look like. So I want you to spend some time on this notebook, go through each and every cell and understand what is happening in each cell. And if you have any questions in understanding as why we have done any specific activity, do let us know in the questions tab. Me or someone from our team will be able to help you. All right. So I hope you guys have enjoyed in this video and you learned something new today. So as you progress in your next learning journey, the next project is about concrete strength prediction. So I'll see you in the next video. In this video, let's look into the solution for this project number 24, which is about concrete strength prediction. So let's perform the activity in a hands-on manner. So let's switch to Google Colab. Now this is a code where we have written to solve the activity of this concrete strength prediction. Now this data set that we have got, that is concrete compressive strength data set, it is from the UCI machine learning repository. So first thing that I'm doing right now is I'm importing the necessary libraries and downloading the data set. Now once this is done, so here we are reading this data as a data frame, and if I describe the shape of this data frame, in this data frame we've got 1030 rows and 9 columns in this data. If I display first 5 entries of this data set, so we've got columns like cement, slag, fly ash, water, super plasticizer, coarse aggregate, fine aggregate, age, compressive strength, and so on. So these are the various columns that we have got on this data set. Now, if I display the information about this data frame, so these are the various information that we have got on these individual columns. So as you can clearly see, almost every one or every column that we have got, it's in numerical format, and we can see that there are no missing values on this data set. So that's clearly an advantage for us. So let's proceed with our analysis. So one thing that we can actually do it, which will help us to perform the activity, is setting up the column names. Okay, so we have to set up the column names. So here, in order to set the column names, so we have mentioned as new column names. So this is a Python list that I have created and mentioned the individual columns. So these are the individual column names that we have specified. And then once I've set the new column names as per our requirement, which is more user friendly. So I have set the column names as cement, blast fly ash, water, super plasticizer. So once I've set this, I'm just setting these new column names as my data frames column name. Now once this is done, we are going to display the statistical summary of this data set. So here, when we display the statistical summary, we are displaying the mean value, standard deviation, minimum, and we have the 25 percentile, 50 percentile, 75 percentile. So this describes the statistical summary of this data. Now, one thing we can clearly observe by just comparing high-level comparison of various columns, we can observe that each column in my data set has its own respective range. It has its own set of minimum value. It has its own set of maximum value. So in case if you are applying any linear regression model, it should be the first activity that we have to scale this data. Then only it is recommended to apply the linear regression model. So that's one thing that we have to keep in mind right now. Okay. So once with this analysis is complete, we can proceed ahead and look into the compressive strength. So I want to understand the overall distribution of data for the output column, that is compressive strength. So with this visualization on the column of this compressive strength, it looks like the distribution that we have got is close to normal distribution, which means we don't have to do any much of changes over here for this column. That's great. Now moving ahead, here let's create a pair plot. So sns.pairplot, and this will help me to create the visualization between the pairs of data set that we have got over here. So let's wait for the plot to appear. So at first glance, clearly we can observe that we don't have any high correlation between any of the features in this data set. And somewhere we can observe that cement and compressive strength look like they may have some correlation, but it's negligible. I mean, we can actually go ahead and validate it right now. So let's do one thing. Let's try to find those correlation in a numerical manner by calling the correlation function on my data frame, and I'm creating a heat map. So once I execute this, this is going to display a heat map with the Pearson correlation coefficients. So as we can observe on this data, so let's try to list down some points over here. So when I talk about the cement and the compressive strength, they have the positive impact. That means cement has a positive impact with its compressive strength. So that is one key thing that we would observe. And another thing that we can observe right here is, so we have got H over here, which is kind of positive, and super plasticizer is, I would say, loosely positive with this compressive strength. So that is what we observe in this correlation plot. Okay, if I want to get the complete idea, maybe we can just go ahead and sort it as well. So currently I'm performing the unstacking, and once we perform the unstacking, if I display my data frame, this is how it would look like. So I'm going to remove the scenarios where it is not equal to 1. So the top 5 correlation between the features are compressive strength and cement, super plasticizer and the fly ash has the correlation between them, and compressive strength and super plasticizer has the correlation between them, and so compressive strength and age has a positive correlation between them. So this is what we observe from this given data set. Okay, for the last three values, we can observe that water and superplasticizers, they are actually negatively correlated to each other. And water and fine aggregate, they are actually negatively correlated to each other. And fly ash and cement, they are actually highly negative to each other. So this is what we observe from this given data. Now, in order to get a better understanding, here I'm creating a scatter plot with Y as my compressive strength, and for my X, I'm considering the cement. So this will help me to establish the relationship between the compressive strength and the cement. And here for the color coding, I'm considering the water column and the age column. So this is like the multivariate analysis that I'm doing right here. So here we can clearly observe this is the overall pattern in the data. We have got loosely correlated in this data set. And one thing that we can observe over here is the compressive strength increases. Okay, this compressive strength correlates positively with my cement, and this compressive strength, so it actually correlates positively with age. That is what we observe from this plot as well. And older cement that we have got, so older cement, they tend to require more water. So that is what we observe right here. This older cement tend to require more water, and the compressive strength correlates negatively with water. And here one more observation that we can make here is the high compressive strength with low age requires more cement. So that is what we can perform an inference from this correlation plot. Okay, moving on, let's go ahead and create the visualization for compressive strength and the fine aggregate as well. So if we do that check, okay, so let's see how it would look like. See, if we do that check, this is how the overall visualization would look like. So from this plot, we can say that this compressive strength correlates negatively with my fly ash. So that's one thing that I would observe from this given plot. And this compressive strength correlates positively with superplasticizer. And these are some of the high level details that we can extract from this given scatter plot. Now, once the EDA is complete, so we can go ahead and prepare the data. Here, to prepare the data, I'm importing my train test split. Then I'm separating my input and the output from this given data set. Split the data into two parts, apply the standard scaler so that we scale the data in an effective manner. Now, once that is done, we are going to apply the model. So we'll be applying the linear regression model, ridge regression, lasso regression, and elastic net. So we'll initialize the regression model and then perform the fit on the given data set. Then here I'm actually using this ridge-CV in order to determine the value of alpha for this given data set. Now once that is done, I'll use the value of alpha. I'll perform the fit on my ridge model. I will do the same thing for my lasso regression as well as elastic net regression. Once that is done, here we are going to generate the metrics that is mean squared error, mean absolute error, and the R2 score. And here, in order to determine these metrics, I'm going to create a custom function. This custom function is going to generate a data frame with the evaluation metric for each and every model that we have just created. So one thing that we can confirm over here is when it comes to the performance, the overall performance of all the linear models are actually same for the given data. The R2 scores are actually closer together when we talk about these various linear models when we apply on this given test data. Okay, so I hope you now have an overall idea as how you can perform the activity of regression in an effective manner. So with this, we come to the end of this video. As we progress in the next video, we are going to get started with the new project, that is project number 25, which is about US baseball salary prediction. So I'll see you in the next video. Now in this video, let's look into the solution for project number 25, which is about US baseball salary prediction solution. So let's get started and let's start coding. I'll switch back to my Google Colab. Now here, this is the implementation of this salary prediction of baseball players. First thing, as always, we'll have to download the data set. So this is going to download the necessary data set. Once the data set has been loaded, we are going to import the necessary libraries. So here NumPy. Along with that, we are also importing the train test plate, cross validation score, grid search CV, linear, and local outlier factor for outlier removal, label encoder, and I'm also importing the standard scaler. Now the file that we have got is a CSV file, which is my hitters.csv. If I read this data as a data frame and display first few entries of this data frame, so this is how the first few entries of my data frame would look like. We've got various columns, so it's a mix of numerical as well as the categorical columns in this given data set. So I can see league, division, and the last column, that is new league. So these are the ones which are categorical in nature, and rest everything are numerical in nature. If I now describe the information of this data frame, so this is the information that I've got for each and every column in my data frame, and display the describe method output. So this is how the output would look like from the describe method. Okay, so we've got minimum, maximum, mean, standard deviation for each and every numerical column in this data set. Now once that is done, so here we are just describing the shape. So in total, we've got 322 rows and I've got 20 columns in this data set. So that is the overall shape of this data frame. Now we will get started and we'll start by detecting the missing values in this data. So data.isNullSum, and we can observe that around 59 entries are missing in the column of salary, and rest everything are actually looking good. So this is what we observe from this data. Now in order to create the visualization of the missing values, so we have to install the missing number package. So pip install missing number. So by default, this is available in Google Colab. In case if you are running and if you face some issues, you can just execute this code, and this is going to install the missing number library. Now, in order to create the visualization, I'll just say import missing number as MSNO and specify the bar chart, and I'll mention my data, that is data frame. So this is going to create a visualization for us and tell us as which are the columns where we see the missing values. Okay, that is what we observe on this given data. Next, once we check for missing values, we'll also check for correlation between the features. So in order to generate and perform this analysis of this correlation, I'm going to apply this COR function, and this is going to result in Pearson correlation coefficient for each and every pair of features in my data set, that is my numerical features. And then I'm going to select wherever the correlation matrix salary is greater than 0.5. Now once that is done, I'm going to select that filter. So I'm applying the filter, okay, where the correlation matrix is greater than 0.5. Once that is done, I'm going to say that SNS.clusterMap, and I'm mentioning those columns correlation values only. That is what I'm doing right now. And at the end, I'm going to create the correlation between the features. See, this is the cluster map that we have got wherever we are seeing the correlation values which is greater than 0.5. Okay, so this is the relationship that we observe on this given data. So we can then go ahead and drop the missing values. So since we have the column salary as missing values, I'm just dropping those missing values. And if I now describe the shape of this data right now after dropping, we now have 263 rows and 20 columns. That's great. Here, I'm just going to sort the data according to the salary, and I'm just ordering it in a descending fashion. Okay, I'm just ordering the data in the format of descending order of the salary. So the maximum salary over here is 2640. This is what we observe on this given data. And one thing that we have to do before we perform any analysis is we will have to take care of this categorical data. In order to take care of this categorical data, as you know, in this given data set, we've got league, which is a categorical variable. So data league value counts. So this is going to help us to describe as how many number of rows are actually present for each categorical data. And similarly, so if I describe the value counts for new league, this is the overall distribution would look like, and for the division, this is the overall distribution would look like for each of the categorical data. Since we have to perform this activity of conversion into numerical format, here we are applying the get dummies on this data frame. Now once that is done, this will ensure that all the data that we have got is in numerical format right now. Now once that is done, yes, once that is done, we are going to detect the outlier. In order to detect the outlier, we are making use of local outlier factor. Now this is a method that we can use it in order to detect the outlier. So currently we are using the default values of 20 and auto. So these are actually the default values. I'm just going to initialize the same, perform the fit and predict on this given data set. And at the end, I'm accessing the negative outlier factor into my data scores. Post that, I'm going to display this data scores. So this is how my data scores would look like. Now, if I go ahead and describe the box plot of this data scores that I've got. So this is the overall, the scores that I'm seeing right here, the output from this data scores. Next, I'm going to set some threshold. Okay. Threshold.sort, whatever the data that I've got, from there I'm expecting the fifth one. This is just the value that I'm going to select. So we are just taking the fifth value as a threshold value, because the values after the fifth values, that is in decreasing, they are actually decreasing closely. Okay, so this is the overall scenario that I'm going to do right now. So once I execute this, this will perform the filtering, and then this is going to ensure that the outliers has been taken care. Next, I'm going to separate my X and Y. The reason that I'm separating this X from my given data set, because these are all the numerical data for which we have to apply the standard scalar. So applying the standard scalar on this given data set of features. And once we perform this standard scalar, next we are going to perform this activity right here. I'm going to select only this categorical data, and on this categorical data we are going to perform the concatenation with my scale data that I have got. Now once we have prepared the data, we'll separate the X and Y, and once we separate the X and Y, obviously this is followed by splitting the data set into two parts, that is training and testing, implementing the linear regression model. And here when we perform the fit on this linear regression model on this given training data set, I can see the root mean squared error as 327.097. And if I do the similar activity on a ridge regression, the root mean squared error is 322.84. And if we implement the same on the lasso regression, it is 322.175. On elastic net, it is 349. And this is just a method where we are going to describe the overall output on the test data. So on the test data, see, this is the output that we see, which describes the evaluation outcome on my test data. All right, team. So as part of your learning journey in this video, you have completed the project number 25, which is on baseball salary detection. So in the next video, we are going to have a conclusion video on this learning journey. So I would like to take this opportunity to thank each and every one of you for staying with me till the end. So let's conclude this session in the next video. Now post that, if there are any future updates, you will be seeing me adding those videos at the end of conclusion lecture. So thank you so much guys, and I'll see you in the next video.